Hi everybody, there was a slight omission in the last example worked in lecture 38, so I wanted to address that now and make sure that it didn't cause any confusion. So you will remember that in that example we were finding all minimal sums for Rn1 as a function of Q, D, N1, and N2. So here's the Carnot map. Rn1 is the function, and then we have Q and D here on the vertical axis, and N1 and N2 on the horizontal axis. And in our example, we identified all of these prime implicants, and we also identified these essential prime implicants, and therefore these three essential prime implicants, as we would expect, they are in every minimal sum that we identified. They are the first three terms, and of course that's always going to be the case, that the essential prime implicants, that all of them will appear in every minimal sum. And so as usual, after identifying the essential prime implicants, we have shaded those in because we know they will be accounted for in any minimal sum we write down, because that's what we're going to start with. As you can see, we've started with these three terms here for this minimal sum. We started with the same three terms here, and that's because those are the three essential prime implicants. And so once we've shaded in those three terms, then what remains is these three cells here. We need to come up with extra terms to include that will account for those three. And of course, we're going to choose from the prime implicants that we identified. And if you look in this first minimal sum, Q prime D prime N1 plus D N1 N2 prime, that's what we added to the essential prime implicants for the first minimal sum. And just to make sure you understand, that would be this prime implicant up here on the top row, and it would be this prime implicant. On the other hand, for the second minimal sum that we identified, the two terms that we added to the essential prime implicants were QD N2 prime and Q prime N1 N2 prime. Now if we look at our prime implicants to try to figure out which ones those were, QD N2 prime is shown right here. So that's this term, and this term is that prime implicant that is formed from these elements on these opposite edges. So again, it's this term and this term, and then the Q prime N1 N2 prime, as you can see right here, that's these two terms. But actually, the minimal sum that was omitted is the easiest one of all to see, I think, and that's the one that we get when we add this prime implicant right here and this prime implicant right here to the three essential prime implicants. And so but somehow that got omitted, and so I've done that here. So here is the third minimal sum that you should have for this problem. And notice, like the other two minimal sums, it begins with the three terms, with the three essential prime implicants, and then the last two terms that we're going to add are Q prime N1 N2 prime, which is, as you can see right here, that's these two ones, and then we're going to also add D N1 N2 prime, which, as you can see right here, is those two terms. And notice that this this expression here has 5 total terms, each of which has 3 literals, and the same can be said for this minimal sum and this minimal sum. So this is just as valid a minimal sum as the other two, because it has exactly the same number of terms with the same number of literals, so it is just as legitimate as they are. And so it should be included in the discussion of this example. So that's it. That concludes this short remark, and good luck.